Hello friends, our today topic is geometric transformation in CAD. First of all, we see what is geometric transformation. It and it can changes the orientation, size and shape of the object in the database as well as on the graphics images as shown in figure below. This alter the coordinates description of objects. This image original object with normal vector shown in red. This is the vector, and this image is same transform is applied to normal vector and object. This image transformed object with the correct normal vectors. Now, use of geometric transformation. The geometric transformation are used for the following purposes: in a construction of a model, in editing the model using the commands like translate, rotate, zoom, mirror, array, etc. For obtaining orthographic, isometric, and pros- perspective views of the models. To view the model from different position and in animation. Basic geometric transformation. The basic geometric transformation used in modeling are translation, rotation, scaling, reflection, shear, concatenated, composite transformation. What is reflection? These are like mirror images as seen across a line or a point. What is translation? This moves the figure to a new location with no change to the looks of the figure. Rotation. This turns the figure clockwise or counterclockwise but doesn't change the figures. Translations. Now we see in details the translation. A translation is a transformation that slides a figure across a plane or through space. With translation, all points of a figure move the same distance and the same direction. Translation. If a figure is simply moved to another location without change to its shape or direction, it is called a translation or slide. If a point is moved A units to the right and B units up, then the translated point will be x plus A and y plus B. If a point is moved A units left, B units down, then the translated point x minus A, y minus B. Example, image A translate to image B. As you can see, this image is translated to this image. Moving to the right 3 units and down 8 units. Moving 3 units right and down 8 units. The the image A is in 2 and 5. 2 and 5, and now image B is 2, 3, 2 plus 3 and 5 minus 8, that is 5 minus 3. Now rotation. A rotation is a transformation that turns a figure about around a point or line. Basically, rotation means to spin a shape. The point a figure turns around is called the center of rotation. The center of rotation can be on or outside the shape. As for example, 1 2 minus 2 1 and 6 2 minus 2 6. When a figure is rotated 180 about the origin, multiply both coordinates. Minus 1 xy is minus x minus y. That is example 1 2 is minus 1 minus 2, 6 2 is minus 6 minus 2. As you can see in the image. Angle of rotation. In a given rotation where A is a figure and B is a resulting figure after rotation, and x is the center of the rotation, the measure of the angle of rotation AXB is twice the measure of the angle formed by the intersecting lines of reflection. Given example, given segment AB to the rotated oval lines L and M, which intersect to form a 35-degree angle, find the rotation image segment KR, as we can see in the image. Rotation. An image can be rotated about a fixed point. The blades of a fan rotate about a fixed point. An image can be rotated over two intersecting lines by using composite reflection. Image A reflects over line M to B. Image B reflects over line N to C. Image C is a rotation of image, as we can see in the image. Image A is reflecting B, B is reflecting C. Since the angle formed by a line is 35 and the angle is rotation is 70, draw angle AXK so that its measure is 70 and AX is equal to XK. Draw angle BXR to measure 70 and BX is equal to XR. Connect K to R to form the rotation image of segment AB, as we can see in the image. What is reflection? A reflection is a transformation that flips a figure across a line. A reflection is flipped over a line. Reflection. You can reflect a figure using a line or a point. All measures, lines and angles are preserved but in a mirror image. The figure is reflected across line. You could fold the picture along line L and the left figure would coincide with the corresponding parts of right figure. Reflection across the x-axis, the x values stay the same and the y values changes sign. Xy is x minus y. Reflection across the y-axis, the y value stays same and the x value change sign. Xy is minus xy. Example, in the figure, line L reflects across the y-axis to line N. 21 is minus 21, 54 is minus 54. Reflects across the x-axis to line M. 21 is 2 minus 1 and 54 is 5 minus 4. X, as we can see in the image. Example, reflects the figure across line y is equal to 1, 2, 3 is 2 minus 1, minus 3, 6 is minus 3, 4 and minus 6, 2 is 6, 0, as we can see in the image.